Hey scholars, welcome to chapter 21-4, where instead of reusing or recycling, we're taking a closer look at what else we could do as a last-ditch alternative, in this case burning or burying our solid waste. So we're going to dive into it today. The first one says waste-to-energy incinerators. We're going to look at the disadvantages and the advantages of burning our solid waste. When you burn waste, you can extract energy from that. When you burn anything, it can be used as a fuel source. So burning municipal solid waste actually to boil water, to make steam, to actually turn a generator and then produce electricity. And that's how it kind of usually works here. As far as the waste incinerators, waste energy incinerators, there's 600 in the entire world. Most of them are actually in Great Britain. There are 98 in the U.S. and I was fortunate enough to actually see one in the town of that my university was in Mount Pleasant, Michigan. The advantage is that it does produce electricity and reduces the whole volume of solid waste by 90% because you're burning it, and the only thing that's left over is ash, as well as the disadvantage here, air pollution, as well as CO2 addition. Anytime you burn anything, CO2 is a byproduct of the combustion reaction and therefore contributes to global warming. Also, you have bottom ash and fly ash, and there's also some pollutants that can get there, not only just CO2, but other things like if you burn batteries or things like that, mercury and some other dangerous chemicals that can get into the atmosphere. So those are some advantages and disadvantages of waste-to-energy incinerators. This is kind of how it looks. You have your waste pit where your dump trucks come and dump all the material. The crane comes down, reaches in and grabs all the material, puts through a furnace which burns, causes heat to boil the water. The water then turns to steam, which helps turn a turbine and generate electricity, and the rest of it comes out after that water has gone through. It can go through a wet scrubber and bring out the dirty water, which ends up combining with fly ash. As that dries out, that fly ash can then be taken to a landfill and deposited where it is obviously much smaller amount of buried waste than it would normally be if you would just dumped it into the ground. So let's take a look at some trade-offs. Advantages: does reduce the volume of trash, less need for landfills, lower water pollution, concentrates hazardous substances into ash for burial. Again, but if it doesn't, it can, during the burning process, it could release those as well, but we'll talk about that as a disadvantage next. Sale of energy reduces cost. Modern controls reduce the air pollution with some filtration, which is good. Some facilities recover and sell metals. And then the disadvantage is obviously it's a power plant. It's expensive to build. It costs more than short-term hauling to a landfill. Difficult to site because a lot of people don't want that in their backyard because it's just kind of gross to produce. I remember in Mount Pleasant, it produces like kind of like not really a hazy fog, but puffs of clouds and things like that. It just kind of look dirty overall. Some air pollution and CO2 emissions. The older and poor managed facilities can release large amounts of air pollution. I know the one that we had on campus was much cleaner than most of them. They actually said that a majority of the chemicals that were being produced weren't even harmful, or if there were any chemicals whatsoever. Most of it was water vapor, they said. The output approach, it is still an output approach. We always want to prevent making waste, but it is an output approach. And it compete with recycling for burnable materials such as newspaper. That's a lot of what they burned in Mount Pleasant was paper. We went through a lot of paper at the university, and that's a majority of what they burn. Instead of recycling the paper, they would burn it instead and use it as a fuel source to power the university. So that was parts of the university. That's kind of a couple of the things there that were a little bit, some trade-offs there. You're still getting energy, but you're burning it to get it. Burning solid waste has advantages and disadvantages. Open dumps. There are you can do a couple different ways of burying instead of burning. Open dumps where they're basically just holes or fields in the ground where garbage is going to need deposited and sometimes burned if needed to make more room, I guess. Sanitary landfills are what a majority of the United States is moving towards and are kind of already have enacted. And that's where solid waste is separated out into thin layers, compacted by a compactor, and then buried and then covered daily with a fresh layer of plastic or foam, increasing dryness, as well as then once it kind of covers over with a layer of dirt to help decomposition. And that's mostly what we have here in the United States nowadays. And this is kind of what a state-of-the-art sanitary landfill will look like. Most of them are not state-of-the-art, I would say, especially the one in Jacksonville, North Carolina is not state-of-the-art, but it is pretty well maintained. What it does have is obviously we have our compacted solid waste. There is a tube to release methane gas through the decomposition process. If not, you'd have methane gas building up, which would not be good. That'd be dangerous. In this case, the methane is then used to burn and generate electricity. In the case of Jacksonville, we don't have that here at the waste of the sanitary landfill in Onslow County. Here we don't have this methane gas hooked up to it. as far as using it to burn and produce electricity. It is just released or burned directly into the atmosphere, which again increases global warming with CO2 emissions. One of the things they have here, which they do have, are some leachate pipes, which it can prevent leak. Pipes can leachate from the bottom of the landfill, so it's not not necessarily becoming hazardous to our groundwater. There's also leachate monitors to monitor the water and making below the aquifers below the landfill to make sure that the groundwater isn't being contaminated. And it also is layered with we've got clay, sand, topsoil. On the layer there, you also have that on the bottom, and usually there's some sort of seal at the bottom, some sort of plastic seal that stops some of that leachate from getting into the groundwater as well. So let's take a look at our trade-offs for sanitary landfills. There's no open burning, which is good. Little to no odor. It's debatable. Low groundwater pollution if site is made properly, kind of developed in the modern way. Can be built pretty quickly. Low operating costs. Can handle large amounts of waste. The filled land can then be used for other purposes, like in Michigan, above my hometown in Mount Brighton. It's a ski resort in the wintertime and in the summertime. It's big. It actually around the bottom of the mountain, as they call it. They call it Mount Brighton, but it really was a landfill. And it's huge. It has enough to ski and snowboard down. But in the summertime, it becomes a golf course. So those are can be used for many different purposes other than just for storing trash. No shortage of landfill space in many areas. A lot of areas can have that's what they use the landfill. Disadvantages: noise, traffic, dust is a big one. Air pollution from the trucks and things. You're obviously releasing greenhouse gas if you don't, even when you burn the methane to use as an energy source or burn it when it's coming out of the pipe, it still is releasing CO2. Very slow decomposition because they're drying out stuff. It definitely slows decomposition process. It's still an output approach again, and eventually leaks and it can contaminate groundwater, which is a bad thing. So those are a couple of kind of secondary, really we use them too much, but methods that should be kind of last ditch as far as dealing with waste and just normal waste itself. Definitely want to recycle, reuse first, and then maybe even try to build products that are more easily recycled and reused. So that brings us to the end of this. Next time we're going to look at the hazardous waste and how should we deal with hazardous waste, stuff that can't really, maybe not be recycled. What are we going to do with it that really could cause harm to the environment and ourselves? So we'll look at that next time. See you guys next time.